Hey everyone, in this lesson, we're going to be talking about how do we graph quadratic functions or parabolas in standard form, but this time without using a table. So in one of the prior videos and one of the prior lessons, we talked about how do we graph parabolas by using a table of values, which in that case, you would have to plug in the values to fill out the table completely, and then plot the points individually so you can figure out what the actual parabola is going to look like. So just a quick little recap. Parabola is the name of the shape that the quadratic function gives whenever you graph it. Typically, it looks like a symmetrical U shape, either going up or down, depending on the following things. So the standard form equation for a parabola is f of x is equal to ax squared plus bx plus c. And depending on these values, well, actually, to be more specific, depending on one of these values, you get a lot of information from what the actual final graph is going to look like. Specifically, the value of a, which is the number that's in front of the x squared. So let's go over each scenario. So when a is a positive number, we established that the parabola will be going upwards, right? So it's going to be a parabola going up. If a, the number, is negative in front of the x squared, then the parabola will be upside down and therefore it will be inverted or going downwards. So it's the opposite. So that's the first thing that it gives us. So it tells us whether it's going to be going up or down. Another thing that the value of a gives us is whether it's going to be a wide parabola or whether it's going to be a skinny parabola. So when the value of a is between 0 and 1, aka when it's a fraction that is less than 1, so that means that it's going to be a wide parabola. And when you have the value of a that is bigger than 1 or much bigger than 1, that is an example in which you're going to have a narrow parabola. So it's either going to be fat or skinny. In this case, if you have a fraction that is smaller than 1, it's going to be wide. And if the a value it's a value that's bigger than 1, depending on how much bigger than 1, it can either be 100, 1,000, then it's going to be really, really, really narrow. The bigger it is, the skinnier it is, right? So it's either going to be wide or narrow. So those are the four things that the value of a gives us. If all else fails and we know the value of a and we know these four things, then basically that'll, by process of elimination, that'll guide you to the correct answer. The last thing that we're going to be looking at is the y-intercept. The y-intercept is the point in which the graph crosses the y-axis. And then we already established in one of the previous lessons that all you have to do to find the y-intercept is set x equal to 0. Okay. So now that we established those facts, let's go over what it is that we're going to be using to graph the parabolas in this lesson. And the only thing you really, really need to know is the vertex. The vertex is very important. Goes by many names. One of the names is the vertex. Another couple of names are either the minimum or the maximum. So when you have the minimum point or the maximum point, they're also talking about the vertex. In the vertex. In this case, the vertex is a min. In this case, the vertex is a max. Right here, the vertex is a minimum value. Again, it's a minimum point. And right here, again, it is a minimum point. Okay, so depending on the orientation, whether parabola is going up or down, you're either going to have a vertex, which is a maximum point or minimum point, either at the top or at the bottom. How do we find that maximum or minimum point? There is a formula for that. So the vertex point, right, the point that's at the very top or very bottom of a parabola, is a point with two numbers, h and k. We don't use x and y just to avoid confusion. Usually they use h and k. H is the x coordinate, k is the y coordinate. So how do we find the h and the k? Really simple. All we have to do is plug it into this equation to find the h. H is equal to opposite b over 2a. Don't forget there is a negative sign in front of that fraction. So it's opposite b divided by 2 times a. And then once you figure out what h is, if you want to figure out the k, all you have to do to find the k is you're going to plug in or substitute the result into the original equation. So k is the result when you substitute or plug in h as the input. So you plug in the h, simplify it, and then you get your value of your k. Okay, so that's how we find the vertex. Okay, well, let's say we found the vertex, right? And we figure out the parabola is going to be going up or down, blah, blah, blah. How do we actually graph the parabola? So these are the following steps. I highly recommend, if you guys are watching this video, to pause the video, write down the steps, because you're going to be using them over and over and over again. So these are the steps. So first thing, you're going to be making a prediction about the parabola using A. We already talked about what that is, what that was earlier, right? The value of A. So is it going to be wide or narrow, like fat or skinny? Is it going to be going up or down? You can make that prediction just looking at the value of A. Then we're going to be finding the x-coordinate, or h, right, of the vertex. In this case, the x-coordinate of the vertex is defined by the formula h is equal to negative b, or opposite b over 2a. So find the h. Once you find the h, step 3 is to find the k by plugging in the value of h, substitute h, into the original equation and figure out what k is. Once you have that, you're going to be plotting the vertex, so basically graphing the vertex, which is just a simple point, right? X and Y. Then step 5, you're going to plot the axis of symmetry. Axis of symmetry is just a fancy way of saying the line of reflection, or the reflection line, which goes right through the middle of any parabola. Step 6, you're going to be using the first term. Now, this is something that not a lot of math teachers teach you, but I'm going to teach you the way how I do it in this class. You're going to be using the first term, which is ax squared, with a equals 1 and a equals 2. You're going to plug in a equals 1 into this. You're going to plug in a equals 2 into this whenever you're graphing it, to figure out where are the neighboring points going to be. After you find the first one, well, we need a couple more to be able to graph this parabola correctly. Once you figure out the neighboring points, then you're going to be reflecting them. So reflect the points over the axis of symmetry, or the line of reflection, right? Same thing. And then finally, we draw the parabola and verify the prediction. The prediction should be correct. If they're not correct, then you probably did something wrong. Step 9, you can check your answer by plugging in a few points. I recommend you guys doing that. If you guys don't have a computer at home, or if you have like Desmos, you can check them with Desmos as well to make sure your answer is correct. So, okay, here we go. So let's do an example. Example number 1. So they give you this random parabola, right? And they say, okay, graph it. They say, what is the graph of y equals 2x squared plus 4x minus 5? So let's start with the beginning. So step 1 is to make a prediction. Oh, that's an ugly one. So step 1, make a prediction. So the first thing we're going to be looking at is the value of a. The value of a is positive 2. So we know that positive 2 is bigger than 1. So is that going to be wide, or is that going to be skinny? If you remember, when a is bigger than 1, when the larger it is, the skinnier it is. So this is going to be narrow. And not only that, is the parabola going to be going up or down? If you notice, in this case, the 2 is a positive, so it's going to be going upwards. So we know 2 things for sure. We're going to be having a narrow parabola that's going to be going upwards. Okay, so we did that already. Now, the next thing we need to do is find the h, which is the x-coordinate of the vertex. To find the vertex, we're going to be plugging into the formula h is equal to negative b over 2a, or opposite b over 2a. We know a couple of things already from these values. So we know the value of a, the value of b, and the value of c in that specific order, right? So that's a, that's b, and that's c. B is always in front of the x, c doesn't have a variable, and then a is always in front of the x squared. So since we have those values, we can figure out that opposite b, in this case, the b would be this value right here, which is positive 4. So I'm going to be plugging in positive 4 there. So it's going to be the negative of positive 4, which is going to be negative 4. And then we're going to take that and divide it by 2 times a. So in this case, we said that a was positive 2. So this is going to be going over 2 times positive 2. And we made a yellow, so let's go ahead and keep it that way and make this positive 2 yellow. All right, so there we go. We have our values of plugged in of b and a. That's all we need to find the x-coordinate of the vertex. So we get negative 4 divided by 4, which is going to give us negative 1. So this is my h. Remember, the vertex is 2 points, h and k. So we have the first coordinate. Now we just got to find the k. How do we find the k? If you remember from the steps, all we have to do is plug h into the original equation, and whatever answer you get, that'll be your k. So let's go ahead and plug it into the original equation. So the next step, which is step number 3, we're going to find k. So k is going to be whatever I get when I plug in the x-coordinate of the vertex into my original equation. We've done this a bunch of times before, so it shouldn't be that difficult to do so. All we're doing is plugging in values in here. So instead of the x, we're going to be plugging in the value of h. And in this case, the value of h is equal to -1. So everywhere where you see that parentheses, which happens to be the same place where you see the x's, so 2x squared plus 4x minus 5, instead of the x's, we're going to be plugging them in with -1. So this is going to be -1 here, this is going to be -1 there. Okay, everywhere where you see an x, we're going to plug in h, which is -1. So then we're going to be simplifying this. Again, don't forget the order of operations, PEMDAS. First, you have to take the exponent and then you multiply afterwards. So this is going to be 2 multiplied by 1. This simplifies to -4. This simplifies to -5. We just drop it down. And then the final answer will be 2 minus 4 minus 5, which is going to give me -7. So there is my second coordinate of my vertex. So now my vertex, which is either my maximum or minimum point, we just figured out that it's going to be -1 comma -7. So we know that much for sure, right? So the vertex is -1 comma -7. Okay, so now that we have the vertex, let's graph it. Let's figure out where it is. So we go to the left one and then down 7. So starting in the middle, right, we always start at the origin. We're going to go to the left one and then down 7. So to the left one space, down 1, 2, 3, 4, 5, 6, 7. This is my coordinate for my vertex. Then what we also want to do, the next step says plot the axis of symmetry. So that was step 4, plotting the vertex. Step 5 is plot the axis of symmetry, which is basically just the line going through that point. So it's a vertical line. It's always going to be a line going up and down, going through that point. So I like to call this the line of reflection or the line of symmetry, or most math books call it the axis of symmetry because it's a straight line. However you want to call it, it's basically the line of reflection. Okay, so now that we have that line of reflection already drawn, ready to go, now let's figure out where the next couple of points are. So this is now step 6. So step 6, I'm going to do this on the right-hand side, so there's space. We're going to plug in a equals 1, and we're going to be plugging it into the first term, which is 2x squared. But we're going to be plugging in with a equals 1 in this case. Or I should say x equals 1 in this case. So let's fix this. I think on the notes it said with a equals 1, but that means we're going to be plugging in x equals 1. Excuse if there's confusion there. So let's plug in 1 for this value. So 2 times 1 squared. That'll give me 2 multiplied by 1, because we do this first. Remember, we first squared and then multiply. And then we get the final answer to be 2. Okay, now we're going to do the same thing, but we're going to do it with x equals 2. Same exact idea. We're going to take the first term, which is 2x squared, but we're going to plug in 2 this time. So this is going to give me 2 multiplied by 2 to the power of 2. We first do this. This is going to give me 2 multiplied by 4. And then when we multiply those two together, we get the final answer to be 8. How does this help me? Why do I give a hoot about this? So what we found out is that we found the first coordinate of the vertex, right? Which is that red point that you guys see on the graph. Then if we go one space over to the right side, right? One space over to the right side, what this tells me is that my next point is going to be 2 spaces up. So when I go to the right 1 space, I have to go up 2 spaces, which means that my next point is going to be right there. Similarly, if I go 1 more space to the right, so now I go 2 spaces to the right, I have to go up 8 spaces in total. So starting with the vertex, I go 2 spaces to the right, but that means I have to go on the y-axis up 8 spaces, 1, 2, 3, 4, 5, 6, 7, 8, which means that there is my next point. So you basically already know what the graph is going to look like. All we have to do is just reflect it, right? So if I take this and I flip it over, this is the line of reflection. So if I go 2, notice that it's a distance of 2 away from this point, or from the line of reflection. I'm going to be doing the same thing on the opposite side. So 1, 2 spaces to the left. And there is my next point. If I do the same thing with this point here, that is 1 space away from the line. If I go 1 to the left, that'll be the exact same thing as this point here. And there you have it. So my final graph of the parabola is this graph right here, which Try to make it as curvy as you can. It should look kind of like a letter U. Let's see if our hypothesis is actually true. So we said in the beginning that it's going to be a narrow parabola, so it's kind of skinny, and it kind of is, right? And it's going upwards. And then it does fulfill all the requirements so that we know we graphed it wrong. If you want to check your work, you should check your work by plugging in a couple of points and see if that actually gives you the correct y value. So for example, let's say I want to figure out if I did this correctly. Now, let's say I'm just going to check, just to be safe, let me just check this point right here, right? So I'm going to check that point. That point is at x equals 1. So when x equals positive 1, which is that point right there, I should get that my y value should also be 1, right? So when I go ahead and plug it into my original equation is right above here. It is 2 times something squared plus 4 times something minus 5. Instead of that x, I'm going to be plugging in x equals 1 to see what I get. As you can see, we have to simplify this first. So it's going to be 2 times 1 plus 4 minus 5. This is going to give me 2 plus 4. That'll give me 6. 6 minus 5. That'll give me 1. So then my y value is going to be 1. So therefore, this point right here is correct. 1, 1. You could always check your answer by doing it that way. I also graphed it on Desmos. If you guys want to check your work, plug it in on Desmos. If you guys have it on one of your cell phone applications, or you have a computer nearby and you want to plug it in. This is what I did with Desmos. The function was 2x squared plus 4x minus 5. If you notice, when I look for my vertex, the vertex is at -1, -7, so that's actually 100% true. The y-intercept is at 0, -5, so it crosses the y-axis at -5, and it goes upwards. So that is the graph that it gives me here. Okay, so as we can see, everything else matches, right? So the same vertex, the y-intercept is right here, where it crosses the y-axis at 0, -5, and then it goes upwards. So you could always check your work using Desmos, or you could always check your work by plugging in points. Okay, let's look at another example really quick. So example number 2. Let's graph this by following the steps that we did earlier. Same thing, let's make a prediction, graph it, and see what we get. So first thing we need to do is look at the value of a. So the value of a is the number that's in front of the x squared, which in this case is -1. So the -1 is our value of a. So let's make a prediction. Is it going to be going up? In this case, the answer is no, because it's a negative number. So it's going to be going down. Is it going to be really skinny, really fat, or normal? In this case, since the value is exactly 1, it'll be just like a regular U, not too wide or not too wide or not too narrow, not too fat, not too skinny. It's basically just a regular U shape. And then finally, we just have to just do the rest of the points. So let's do the rest of the process. So the first thing we need to do is find the vertex, right? So let's find the vertex to figure out where that actually is. So the vertex, first we have to find the h. H is opposite b divided by 2 times a. So opposite of b, that'll be opposite of the value of 6, right? So if this is a, this is b, and this is c, opposite of b will be opposite of 6. So I'm going to plug in the 6 right there, and then put it on the bottom, 2 times a, which happens to be -1. When we simplify this out, we get -6 divided by -2, which simplifies to just the value of 3. So we found h. How do we find k? Step number 3 says find the k by plugging it into the original equation, and that'll give you the value of k. So k, when we take this equation, so notice that the equation is different now, so I'm not going to plug it into the one that I already did. I'm plugging it into this one because it's a totally different graph. So the equation will be -1 times blank squared plus 6 times blank minus 5. What goes in this blank? Well, the value of the x, or in this case, the h, is going to be going in this blank. And the value of h that I'm going to be using is 3, because the answer for h is 3 this time. So let's figure out what k actually is. First, we have to square it, and then we multiply by the -1. So the first term is going to be 3 squared is 9. 9 times -1 is -9. 6 times 3 is 12. Oh, that is not true. 6 times 3 is 18. And then minus 5, we just have to simplify that out. So 18 minus 9 will be 9. 9 minus 5 will give me the value of 4. So there you have it. You have the h and the k value, which is the vertex, right? So my vertex, which is the point, h comma k, right, either the maximum value or the minimum value, is the following. The vertex was found to be 3 for the h and 4 for the k. So it's 3 comma 4. So those are my coordinates of my vertex, which we have to graph, right? We have to plot it to figure out where that is. So when we graph 3, 4, that means 3 to the right, up 1, 2, 3, 4. They're both positive, so it's going to be right there. That is my coordinate of the vertex. Now that I have that plotted where it should be, I'm going to go ahead and make the line of reflection, the line of symmetry, right? So just basically make a line going up and down. It's always going to be going up and down through the vertex every single time because parabolas are always symmetric. So as soon as you graph that vertex, always draw the line of reflection or the axis of symmetry, same thing. So now that we have the line of reflection, we're going to be using the first term, right? So remember we talked about the ax squared. We're going to be using that, and we're going to be plugging in x equals 1, and we're going to be plugging in x equals 2 to get some neighboring points around that vertex. So in this case, the value that I have here for ax squared would be this value here, which is -1 x squared. I'm going to be doing that, and I'm going to be plugging in two things. The first thing I'm going to be plugging in is x equals 1, and the next thing I'm going to be plugging in is x equals 2, and simplify. That'll give me my next 2 points that are right next to that vertex. So when I simplify the first one, don't forget, first you need to square it, and then you need to multiply. So don't forget about PEMDAS. 1 times 1 is 1, and then times -1 will give me -1 as my first answer. If I do the next one, first we have to square it. So that'll be 2 times 2, which is 4, and then 4 times -1 is -4. So that'll be my second answer. When I graph this, so remember, I always start at the vertex. I'm always going to start at that center, or actually at that maximum or minimum value. So from here, I know that if I go one space to the right, this tells me that my y is going to be one space down. So when I go one space to the right of this vertex, I'm going to be going one space down below this vertex. And therefore, there's my next point. If I do the same thing for the next one, now if I want to graph this, I'm going to be going 2 spaces to the right, so 1 over again, and then this tells me that I have to go 4 spaces down, so 1, 2, 3, 4, which means that my next point should be right about there, right on the x-axis. So the last thing that I need to do is reflect those 2 points over the line of reflection, so I'm able to graph it. So let's go ahead and do that. If I reflect the first point, it's going to be the same distance on the opposite side of the line, which is going to be right here. If I reflect the second point, which is on the x-axis, is 2 away from the line of reflection, so I'm going to be going 2 away on the left-hand side also. So there you have it. Once you guys have all the points that you need to be able to make this graph adequately, you can go ahead and connect the lines as well as you can. And there you have it. So you have your parabola. Now let's figure out if it actually matched what we said. So we said in the beginning of the problem that this parabola was going to be going down, and it is. And we said that it's going to look like a regular U shape, and it does. So make sure you always verify your answer. And if you still don't trust this process, let's verify with Desmos. So I already went ahead and graphed this with Desmos, the Desmos graphing calculator. So this is what the graph gives me. So y equals -x squared plus 6x minus 5. As you can see, the vertex is a maximum point at 3, 4, so 3 to the right of 4. It also touches the x-axis at x equals 1 and x equals 5. And if you notice, that's the same graph that I got. So this is the vertex, which is at 3, 4. It touches the x-axis at x equals 5 and x equals 1, which is exactly what we have here on this graph. Okay. Going a little bit further, if you wanted to figure out what the y-intercept is, you could actually still do that, right? So the y-intercept crosses the y-axis at this point, which is 0, -5. If you notice, it also crosses at 0, -5 here. But then again, you could always get that by plugging in x equals 0. Anyways, moving on. So I do have a couple of examples for you. So I did 4 total. I know it's kind of a long video, but I figured the more examples, the more clear it's going to be when you actually have to do this on your own. So let's try example number 3. Let's graph this. I'm going to be going a little bit faster now. So the first thing we need to do is figure out what predictions can I make. So what predictions could I make? The first thing is a is equal to -3. So the fact that it's negative, that means that it's going to be going down. This parabola will be going down. The fact that it's a number that's bigger than 1, it's going to be a skinny parabola. So it's going to be going down and it's going to be thin, a thin parabola. So that being said, let's do the rest, which is to find the h and the k. So 2, h is equal to opposite b divided by 2a. In this case, we have the values of a, b, and c. So a is equal to -3, b is equal to -12, and then c is equal to -5. If I plug this in, I get negative b, which is, in this case, is -12, divided by 2 times a, which is -3. So that -3 came from the value of a, and that -12 came from the value of b, which happens to be right there, right? Corresponding to a, b, and c. So all we have to do now is simplify. H is going to be 12 divided by -6, which is going to give you -2. So the h is equal to -2. Now let's find k. So third step, find k. We have to plug it into the original equation, which is this one right here, right? Don't go back to doing another example. It's this one. So -3 times x squared minus 12 times x minus 5. But instead of the x, I'm going to be replacing that with my value of h, which in this case, the h would be -2. So let's plug in -2 into both of these points, or both of these blanks, and simplify. So -2 goes there, -2 goes there. So let's simplify now. Last thing we need to do is simplify. This will give me 4. 4 times -3 is -12. -12 times -2 will be +24, and then subtract 5. So this will total out to +12 minus 5 when I combine like terms, 24 minus 12. And then the final answer for this will be 7. +7, I should say. When I go ahead and graph this, or actually, what did I just find? I just found the x and y coordinates of my vertex, right? So the vertex, which is h comma k, in this case would be equal to the point -5 comma +7. So let's graph that. -5, +7, that'll be to the left 5 and then up 7. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. There we go. So my vertex will be that point right here. Next, let's make the line of symmetry, or the axis of symmetry. Again, it's just a line going up and down through that point. So let's just make a vertical line going up and down. The equation of that line in this case would be just x equals -5, if they ask. But here we go. So finally, we need 2 more points, right? So now I'm going to be looking at the first term, ax squared, which in this case, it's -3x squared. And I'm going to be plugging in x equals 1. And I'm also going to be plugging in x equals 2 to figure out 2 neighboring points on the right-hand side or the left-hand side of that point, or that vertex. So let's go ahead and do that. Plug in some of these values. So the first one will be 1, and the second one will be 2. All right, so what color should I pick? Doesn't matter. Let's do this one. So I'm going to plug in 1 for this one, which is going to give me a value of -3 as my final answer. I'm going to plug in 2 for this one, which is going to give me a value of -12 as my final answer. So that'll be 4 times -3 is -12. So when I graph this, again, we have to go starting at the vertex, go back to the vertex. Everything corresponds back to the vertex of the original problem. So when I go 1 space over, I'm going to be going down 3. So 1 space over to the right, I have to go down 1, 2, 3 spaces, which means that this is going to be my next point. When I go 2 spaces over to the right, I'm going to be going down 12. Oof, so it's going to be 2 spaces over to the right, but then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Starting at the vertex, right? So I always start at the vertex. That is it. Now we just have to basically reflect this over the line of symmetry. So that means that there's another point going to be on this side, and there's another point going to be 2 spaces away from that line. And then the last thing we need to do is connect the dots. So we have a parabola that is going downwards. We can see clearly now, right? Excuse my not so straight, not so curvy lines. And it's going down. And our prediction was that it was also going to be skinny, and it looks like it actually is a little thin, right? So it's a narrow parabola. So if you don't believe that you did it right, you could always check your answer by plugging in some numbers or by using Desmos. So let's go ahead and check with Desmos. So I plug in, I did this work already on Desmos, negative 3x squared minus 12x minus 5. The vertex that I got was negative 2, positive 7, which is the exact same thing that we got, right? And then if I zoom out a little bit, it looks like, yep, it's a thin parabola going down, and it is on the top left, that quadrant. And as you can see, it actually matches with the parabola that I have here, okay? It looks a little different just because it's zoomed way in, or way out, I should say. But if you check the coordinates, all the points should actually match up to what you graphed. Okay, so anyways, there's one more. And the only reason why I'm giving you this one is because it actually has a fraction. If you feel comfortable with it already, you can go ahead and start now. The process is the same, but I'm going to give you one with a fraction really quick, just to be safe, for comfort. So let's start from the beginning. So the first thing we need to do is make a prediction. So as we can see, this is 1/2, which means that it's going to be a parabola that is going to be going upwards, and it also is going to be wide or fat, right? Because we have a fraction that is between 0 and 1. So the closer it is to 0, the wider it's going to be. So now that we have that, second thing we need to do is figure out h. H is the formula opposite b over 2a, so negative b over 2a, opposite b over 2a. In this case, we have the values of a, b, and c. So opposite of b would be opposite of 4, which is negative 4. And then we're going to be plugging in 2 times a, which is 2 times 1/2. When we simplify this, on top, I get negative 4. I didn't mess with that. On the bottom, the 2 and the 2 cancel. So we get a 1 left over. When the 2 and the 2 cross out. So we basically are left with negative 4. So now my h is negative 4. We have to figure out what the k is. So when I figure out what k is, I have to plug in into this formula, right? This equation, I got to plug in, instead of the x, I got to plug in negative 4. So 1/2 blank squared plus 4 times blank plus 4. So in this case, we're going to be replacing these blanks with the value of h, which is negative 4. So everywhere you see an x, so this will be negative 4 here, negative 4 there. Okay, so that gives me 16. So 1/2 times 16. This will give me 4 times 4, which is another 16 negative, and then plus 4. So half of 16 is just 8. So 8 minus 16 plus 4, which simplifies out to negative 4. Okay? So what that means is that the vertex, which is the h and the k, those two corresponding together one after another, that'll be negative 4, negative 4. So when we plot the vertex, which is the maximum or minimum value, we're going to plot negative 4, negative 4. So let's start there. So that means to the left 4, down 4, right? So starting at the center, always 1, 2, 3, 4 to the left, 1, 2, 3, 4 down. So this is my coordinate of my vertex. Now that I have that, let's make the axis of symmetry, which is basically just a line going up and down, the line of reflection. So just always going through the vertex as straight as you can. Then we're going to figure out, okay, now that I have my ax squared, we're going to be plugging in x equals 1 and x equals 2 to get two values that are next to the vertex to see how far we're going to be going up or down. So if I do that, the value of ax squared in this case will be 1/2 x squared. So we're going to be plugging in 1/2 x squared for x equals 1 and x equals 2. So let's do that. 1/2 times blank squared, 1/2 times blank squared. For the first one, we're going to be plugging in x equals 1 and figure out what we get. And for the second one, we're going to be plugging in x equals 2 and figure out what we get. Same idea. So on the first one, we have 1 squared, which is 1, and then half of 1 is equal to 1/2, or 0.5. So the first answer is 0.5. On the second one, first we square it, so 2 squared is equal to 4, and then half of 4 is going to give me the value of 2. So my second space over, I have to go a value of 2. So what that means is that when I start, always start at the vertex, right? So remember, we always start at the vertex. So here at that vertex point, if I go 1 square to the right, I'm going to be going 0.5 squares upwards, which means that I'm going to be going half a square. So my next point should be there. If I go 2 squares to the right from that vertex, I have to go up, because it's positive, 2 squares. So that means that my next point is going to be right there. All I have to do now is draw the line of, reflect these 2 points along the line of symmetry, and connect them, and you have your parabola that should be the same thing as what your predictions indicated. In this case, my predictions, or our predictions, indicated the parabola was going to be going upwards, and the parabola was going to be a little bit wide, right? Because we have a number that is less than 1. So if I connect these dots, I know it should be a little more circular, or rounded, I should say. This is the graph that it gives me. So it is a vertex, -4, -4, and the parabola is wide going upwards. Let's see if that actually matches up with what Desmos tells me. So I put this in Desmos, y equals 1/2 x squared plus 4x plus 4. As you can see, the parabola is going upwards. The vertex is at -4, -4, and it is going upwards, and it looks like it's a little wider than normal. 1 square over, I go half, and then 2 squares over, I go 2 spaces up. So it actually matches up exactly with my predictions said where we're going to be. Okay, hope this video was helpful on graphing parabolas by using the vertex. See you guys on the next one.